do now is just take the first part of this sum, which will just leave us with the integral 1 over v to the n times all these volume elements. Now obviously that's just going to give us v to the n over v to the n, which is just 1. Cool? Yeah. So, but now the next thing we want to take a look at is what if we take one of these f of I sub j's? That will give us the 1 over v to the n times d3 r1 d3 should go up here, r2 d3 r to the n, and we'll just take just one of the f of I sub j's. Now this is going to be basically the exact same thing as the previous problem, except we'll be missing out on 2 factors of v to the n. So we'll have 1 over v to the n times v to the n minus 2 times an integral d3, that's eventually going to make it up there, r1 d3 r2 times f of 1, 2. And now that since I and j can be any 2 pairs of particles, we can take this as ij, which goes into 1 over v to the n. What is that? That's not v to the n. We'll cancel out the n and have 1 over v squared times 1 times n by n minus 1 over 2 times the integral d3. The 3 will go up top. 1, 2, r1 d3 r2 times f1, 2. Where this n to the n minus 1 over 2 is just the number of distinguishable pairs. So basically like 1, 2, 1, 3, and then that's the same thing as f2, 1. Awesome. So now what we want to do is introduce a little bit of notation here. Probably shouldn't have erased that integral there because we're going to need it again. But we're going to, let's not do that yet. We're going to take our integral 1/2 n by n minus 1 over v squared integral d3 r1 d3 r2 times f